Alright, today's the first day of solving radical equations, so the steps we're going to go through in solving this. The first thing that you need to do is isolate the radical. The radical. Once you have your radical isolated, then you want to raise both sides. I don't know why my pen is not working. Sorry. Raise both sides to the same power. So that says raise both sides to the same power. Third thing you want to do is solve. And fourth, you want to check for extraneous solutions. What an extraneous solution is a solution that when we solve it algebraically, it works. However, if we plug it, E-O-U-S, then it doesn't work. So that would mean we get an answer, and if we plug it into our square root, it gives us a negative square root. If you plug it in and it doesn't make both sides equal. So one side is negative, one side is positive, something like that. We'll look at some of those a little while later on. So the first example we're going to do, so you can see how all these things work together. The first thing we're going to do is if we have the cube root of 2x plus 7 equals 3. Now, the first step is to isolate the radical. So if you notice, we have the cube root of 2x plus 7. There's nothing else over there with the cube root. So all it is the cube root and the stuff underneath, so it's isolated. The next thing we want to do is raise both sides to the same power. So if we have the cube root of the side, in order to get rid of that cube root, we want to cube it. So if we cube the left, then we also want to cube the right. So we're going to cube both sides. The cube root of 2x plus 7 cubed is just 2x plus 7. 3 cubed is 27. And now we need to solve for x. Step 3 is to solve. So we're going to solve for x. So we'll subtract 7. So we have 2x equals 20. Divide by 2. So x is equal to 10. Always want to plug it in and check. So if we plug it in and check, then we have the cube root of 2 times 10, which is 20, plus 7, which is the cube root of 27, which is 3, which is what my original was, so it checks out. So 10, x equals 10 is our answer. The second equation, or the second example we'll look at, is 54.5 equals 6.3 square root of 1013 minus p. Okay, so there's a lot of decimals and things going on in here, but we're just going to solve it through in the same form and fashion. So the first thing we need to do is isolate the radical. So we have this 6.3 in front of my square root. So it's 6.3 times my square root. So we're going to divide both sides by 6.3. That'll leave me with 8.65. Is equal to the square root of 1013 minus p. In order to get rid of the square root, because now there's nothing else except for what's underneath the square root, in order to get rid of a square root, we will square both sides. 8.65 squared is 74.8, and that's going to be equal to 1013 minus p, because when I square the square root goes away. Going to subtract 1013, so we're left with negative p. And then we do minus 1013. That'll leave us with negative 938.2. That equals negative p, so we know positive p is equal to positive 938.2. Again, we'll plug that in, so you can type that straight into your calculator. 1013 minus 938.2. Take the square root of that, and then multiply by 6.3, and you'll end up with 54.5, and so that is our solution. I'm going to do one more example with you. So if we have x plus 2 to the 3/4 power minus 1 equals 7. In this situation, we still want to isolate the radical, but we don't have the radical sign. We have x plus 2 to the 3/4. We want to get that by itself, and then we'll talk about what to do with that 3/4 power. So the first thing we need to do is add the 1 because we need to move it to the other side. So we have x plus 2 to the 3/4 power equals 8. Now, in order to get that 3/4 power to be a power of 1, because we want to make that exponent go away, we're going to need to raise both sides to the same power. So when we raise it to another exponent over here, we'd be multiplying our exponents. If we want to multiply them together to be 1, we're going to raise it to the reciprocal. So here we raise to the reciprocal power. So since this is x plus 2 to the 3/4, I'm going to raise both sides to the 4/3 power. So if you notice when you multiply these over here, you'd get 12 over 12, which reduces to 1. So you just have x plus 2 to the 1st power, which is just x plus 2. So we have x plus 2. If we raise it to the 1st, again, that's the same thing as x plus 2, equals 8 to the 4/3 power. We know that we can rewrite this as the cube root of 8 to the 4th. So the cube root of 8 is 2. We'll raise that to the 4th power. So we get x plus 2 equals 16. Now we need to get x by itself, so we subtract 2, so x equals 14. Again, we want to plug that in, so if we plug it in, we get, well, let me grab another color for you. We get 14 plus 2. Oops, that was not a different color. That's okay. 14 plus 2 to the 3/4 power minus 1 equals 7. So we get 16 to the 3/4 power minus 1 equals 7. 16 to the 3/4 power is the 4th root of 16, which is 2 cubed minus 1. 2 cubed is 8 minus 1, and that does indeed equal 7, so we know our answer checks out, and this one is okay. So far we've not come across any extraneous solutions. We're really going to see those more so in tomorrow's video, but I want you to know it's there, get into the habit of checking, and that's also another way to make sure you got the correct answer.